All right, hello and welcome. It's Maddie Adams, and today I thought we would stick away from the news. We'll get into some more 3i Atlas stuff and some other outer space news next week. I also just recently interviewed somebody. He has kind of a theory of everything that he's working on. So I'm going to be playing that interview once I get it kind of edited up. So that's what we have kind of going on the next couple weeks. And then, like I said, obviously 3i Atlas is going to be reaching its nearest point to Earth on December 19th. So I'm looking forward to that, and hopefully looking forward to getting more stuff from NASA. So today, though, I just kind of had a fun random idea. What is actually the carrying capacity of our solar system? Now, this is a question that we don't really have the answer to because we don't know that much about other solar systems to make a comparison. But I was just curious, how many planets can we kind of throw in here and get it all wild? Um, I think it should be really fascinating. So let's just start getting some random planets added in here. I think what I'm going to do first, actually, is I'm going to take like a really large gas giant and put it way outside of Neptune. And hopefully, as we add more planets, that should sort of help to balance things out a little bit. So we'll do lever. I like that. And if you know anything about the hunt and the pursuit for Planet X, there may actually be a large gas giant or something out there. So way, way, way out there that we can't see. So let's actually do a second one. And this is something that everybody probably didn't think of. Let me just move my face out of the way here. I just wanted to put my face there so that you know I'm not AI, and I'm never AI. So if you like stuff not being AI, give me a subscribe. I will never be AI. I'm a real human. All right. So, I said there could still be more planets way out there that we just don't know about because it's so dark. So I said we'll do two gas giants really far out. Just kind of let this go for a minute. All right. They're in orbit. Good stuff. I don't think that's going to cause any issues. Do you have any oh, we're gonna have maybe a slight variation in the orbit there. Well, let's get some more rocky planets down here in the middle. We'll do some randoms. Random exoplanets. We'll just put a bunch of them. So we'll put one in closer than Mercury. And I'm going to try to put them kind of at least on the opposite side of their closest planet to start out, just to give us a higher success rate. That is a fascinating, very bright red planet there. Kepler 23c. Alright. Then we have HOP 109600b. Very easy to remember name. I'm assuming we're going to either get collisions or at least changes in the orbit here. Keep doing more random exoplanets. Kepler 1580b. I'm going to try to keep it kind of stable for a little bit, and then we're just going to kind of go crazy. Okay. So let's see. This guy's kind of fascinating. What is this? Kepler 23c. 2.7 masses of Jupiter. Oh boy, that's pretty big to be in the inner planets. I hope it doesn't cause too many issues here. And what do we have here for HIP? 2.68 masses of Jupiter. Oh boy, we got some. I guess if we're picking random planets, the chances are that they're going to be larger rather than small. Alright, now we're getting a little bit closer. Only 97 masses of the Earth for this one. So we've got a lot of new large planets in our new solar system here. Kepler 1863b. We have any collisions yet? Maybe one of these will become livable. I hope so. I certainly do. Alright, check the chat out. How many planets do you think we could fit in our solar system? Or that our sun could reasonably hold? This is fascinating. We're actually doing okay. Let's add some more random planets. It's going to be the most ridiculous solar system ever. Start getting them a lot closer to Earth. And start crossing some of their orbits a little bit. Here we go. Okay, now our sun is moving. What just happened? I must have put something in massive enough that we're gonna get a binary. Oh boy. Let's just let this go. Let's just check this out. Let's watch it. Earth, how we doing, baby? How we doing? Heating up and cooling down. We're way out here now. Freezing and getting hotter. What is our sun moving around for? What has happened to our new center of mass? Venus is ejected. Oh no, Venus. Bye, buddy. Have a nice trip out past Uranus. Let's get back to the inner area here. Yeah, so this must be massive enough. Oh yeah. So this looks like a red dwarf, basically. So even though I'm putting in random exoplanets, or maybe like a brown dwarf. So that was enough mass to get the sun moving, throw us into a binary pair. Earth is, when it gets close to the sun, all of our oceans just boiled. Oh no. Now we're gonna get farther out, get a chance for life again. Before we zip too close to the sun again. Only 235 degrees. Man, we got really hot. We must have came really close to the sun. Let's see how we are. We bossed too close to the sun. Alright. We can see through the atmosphere again. Oh man. Check it out. Dun, dun, dun. Yes, I will always be a real person. I will never be an AI. Oops. Wow. Earth. Earth, where are you? Looks like the moon is off on its own now. No more Earth to tell it what to do. Just orbiting the sun. I'm curious what you guys think. Let me know in the comments. Do you think we will ever reach a generalized theory of everything? What do I mean by that? So right now, essentially, the classical model for physics and the quantum model for physics don't line up. When you get down to the quantum level, things seem to zoom in and out of existence, and quantum physics has its own set of laws that basically don't really make a whole lot of sense. And over time, we've been trying to reconcile that and come up with a unified theory of everything. If Einstein died trying to chase it, many people have tried to, because the idea is if we can get kind of one framework or one mathematic principle, one one, even if it's a very long equation or set of equations, that can explain the entire universe and everything that we see, and we can use it and apply it towards anything in physics. Um, oh, do I have comments turned off? I shouldn't. Let me see here. Okay. I don't think comments are turned off, but maybe your account is in trouble for trolling too much. Let's see. Hey, Earth. We're doing okay now. See, we are not settled into a stable orbit, though, because this was our last orbit. This is going to be our new orbit, so let's see how things look as we approach the sun here. Something tells me we're going to get really hot. Shh. See how close we are. Okay, we didn't get deathly close. Earth might still be livable, but it's gonna be kind of like the three-body problem. We're gonna like go extinct, and then we're gonna come back, and then maybe we'll be alive for a little bit, and who knows, you know? This is getting pretty wacky, though. So I believe this is our binary system now. So K252b has just enough mass where it's kind of pulling on the sun, moving it. It's not quite a binary, but just about. The sun still owns most of the mass in our solar system. Now it's going to be scary when Jupiter and all of its moons come in really, really close here. That's going to be interesting. I'm going to wait for that. Do, 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 do. Let me know if you can hear the background music, if it's too loud, or I'm just going to mute myself real quick so I can listen to it. I don't have an audio engineer. Okay, we'll try that. You should be hearing a little bit of the background music now. Alright. Wow. Let me know if it's too loud, though. I don't want it to overpower. So we're really going to run into our own kind of three-body problem here, where as we get closer to the sun, we're going to turn into a hothouse. Then we're going to get farther away, become livable for a little bit. So if we had any engineers alive on Earth, I would think that they're going to be really, really, really trying to find us somewhere new to live. I'm really curious what's going to happen to Jupiter here. Oh, looks like it's actually on its way out. But this is changing. I love watching it try to do math in real time. That's how you know we don't perfectly understand orbital mechanics. Everything is constantly changing so much. So much math going on all at once. Wow. There we go. Okay. Let's go to the inner solar system a little bit more here. This guy's really close. This is our new Mercury. Oh, these guys are crossing paths, slingshotting. That's pretty crazy. Hat P51b, you know? To be a Hat P51b. I really encourage you guys to look up some of these planets too, because they are randomly observed planets. You know, we don't know exactly what they look like. These are going to be based off of chemical composition that we've received from various telescopes, and based off of that, we'll get some sort of a artist interpretation of what we think the planet looks like. Um, I know one of the famous ones. Just be careful when you see stuff like that, though, because we really don't truly know exactly what a lot of these planets look like, but we have an idea from spectroscopy. But it wouldn't surprise me if it ends up being kind of like how we reconstruct the dinosaurs, where uh, we're going to miss something and we end up getting these solar systems and the planets are likely going to look somewhat different than we imagine or that we thought they would. Mars, how you doing? Mars is Mars still. It's getting slingshotted around too. What do you think? Is Jupiter going to stay or is it going to go? Right now it looks like it's going to go. Before it looked like it was going to oh. I'm going to say some of its moons are going to get sucked off. I don't know. Part of the Jupiter system will stay in orbit, part of it will get ejected, I'm going to guess. What actually happens to Jupiter? That's anybody's guess. 10.8 AU's out right now. And by the way, AU is an astronomical unit, so that is the distance from the Earth to the Sun, or the average distance from the Earth to the Sun. The reason why we use AUs in outer space is because when you start saying, oh, something is 896 million miles away, it stops making sense. So when you get to such large scales, we just start talking in astronomical units and then light years. Let's see here, way on the outside, Neptune seems fine. Same with our two planet X and Y that we put way on the outside. Actually, this guy might get ejected. He might be too far. He might not actually really be in the gravity well of the sun. I might have put that too far out. But Lever 2000, is where we're going to find all of our soap. Not a sponsor. Alright, let's just start adding some more random planets. But actually, I'm going to let it go for a little bit. So I would imagine the answer to my question is that our solar system could technically hold a lot more planets. Now, how stable would it be? That's a better question. And, maybe the reason our solar system is kind of so perfect is because we have just this perfect balance with the four rocky planets on the inside, the gas giants on the outside, balancing out the gravity of the sun, and, it's just kind of in this perfect dance. But could that have happened around our sun? Could the planets in a different scenario have broken into 11 different planets instead of 8? I think it's quite possible. But let me know what you think. I really just want to see Jupiter, if it comes back or not. Where did Earth go? Are we still around? Might have to search for us. Where's Waldo? Oh, man, we crashed into something and I missed it. Because if we got ejected, we would still be on the list. So we'll have to rewind later and see where Earth crashed into something, because it's gone. I'm going to have to figure that out later, and I'll timestamp it. Interesting. Totally crazy. So Earth is gone. That's kind of sad. This is the guy that kind of messed everything up. I said random exoplanet, but I guess technically we're right around the mass where, I don't know, I think this is more of a red giant. And it says it's a star, but that's okay. So we have a binary system now. Everything's going way out of whack. I'm just going to let this run for a little bit. Maybe we'll get some more chaos or another collision here in the inner solar system. We do have some orbits crossing path here. These guys are crossing path. Actually, pretty much everything is crossing a different orbital path. Wow. Oh, here comes Uranus. Okay, this should be interesting. Let's go. Uranus is coming into the inner solar system. It had some Taco Bell and it's ready to mess up everything. Zoom to the perspective of Mars here. Is Mars going to be okay? Is Mars going to get a new moon? Or is Mars going to get sucked right into Uranus? Let's see, might be able to escape here. Margaret, hey? It's an interesting name for a moon. How many of the moons of the solar system's names do you have memorized? Alright, Mars is safe for now, but Earth is gone. Life has been eradicated. What does Jupiter's orbit say? We still have no idea. It's still resolving itself out with the Fibonacci spiral. And Saturn, which looked like it was going to stay... Yeah, we have no idea right now. It's going to take a little while to stabilize out. Looks like Uranus is going to be on a very elongated orbit if it manages to stay. So yeah, I don't know, maybe our sun really can only hold about the amount of planets we have, and that's why it is how it is. But to be fair, things were looking pretty decent until way too massive of a planet got added, and well, actually it's a red dwarf got added in the inner solar system. We were actually doing okay until then. Alright, let's try to make one more gigantic stable solar system. I don't know why it gave me a red dwarf this last time. Oh, let's look at Interstellar Comet 3I Atlas real quick and see where it is now. So what's today's date? 12/2. You can also check out the Sky Live for stuff like this, but I figured since I've been talking about it so much, we'll see where it's at. And then 12/19 is going to be its closest approach to Earth. So I'll pause it at 12/2, which is today. Pause it at 12/19 to show its closest approach to the Earth. Somebody asked me that today when we're going to see the aliens. Alright, so this is tomorrow. So tomorrow it's going to be right here. And then, like I said, the 19th. Boop, this is the closest it's going to be to Earth. So we should be getting some really great, amazing shots now. The sun's halo isn't in the way anymore. The government isn't shut down anymore. We got no more excuses. NASA should be really putting out some great and awesome stuff for us, I hope. Alright. Let's do all planets and all moons. We'll try this again. We'll try to keep it stable, and then we'll blow it all up at the end. So. Let's go here. Random exoplanet. Boom. Switch. Random exoplanet. Boom. Switch. The reason I switch is so I get a different random exoplanet every time. I'm not just placing the same one. Alright. Random exoplanet. We'll put one just outside of Neptune. Boom. Random exoplanet. Put one here. Put one here. And we'll put one here. And we'll put one here. See, some of these are a little too... I'm going to remove this because this already looks like a star. Oh, no, okay. It's a hot Jupiter. We'll let it be. Alright. One here. And we'll put 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 one here. Just gonna keep adding more. This is probably just gonna cause max chaos right away. Max chaos. And you know, why not? Oh, I didn't even pause it, so actually we're still like kind of stable for right now. I think this was... No, that's not our hot Jupiter. Toy boy over here. Let's see. Is it gonna stay stable? We gotta mess with Earth a little bit more. Oh yeah, and I said I was gonna add a bunch of moons around Earth too, but maybe I'll save that for next episode. What's up, good vibes? Make sure I read my comments more often. I'm reading them, thank you. What do we got going on? Come on, something crashed into Earth. Actually, wait, where is Earth? Uh-oh. Here it is. Still looking okay. One mass of the Earth. Imagine now the night sky would look a lot different. Have a lot more big objects up in the sky. But yeah, so I do think our solar system could hold a lot more planets, theoretically. Now, over long scales of time, you think that would increase the odds of instability. And so maybe that is one of the keys to life on Earth, is actually not having too crowded of a solar system where you're going to have too many collisions going on. And that also ties into, you know, being in the right part of the galaxy, right? Being in not too crowded of a part of the galaxy, being in just the Goldilocks and perfect zone of everywhere. That's actually called the rare earth hypothesis, or the rare earth solution to the Fermi hypothesis, which is just that all of the conditions on Earth are so perfect, right? So not just the conditions on the surface of our planet, but the conditions that created our solar system. Like I said, the location of our solar system in the galaxy, the location of our galaxy in the universe. You know, there's a theory out there, a possibility that all of these things have to be just completely perfect in order to work. So, alright, I'm going to blow this up real quick, and we'll see how many moons we can add around Earth. I think we could have a lot of moons. Bye-bye. I just always find this so stunning now. Don't burn out your TV screen. Wow. How do you think Earth is doing in here? We still alive? Or do we just get completely absorbed? Nope. Jupiter. Supernova has destroyed all life. Alright, let's see how many moons we can do around Earth now. And then I'm getting out of here. Alright, so obviously we know our moon is very large in comparison to us, the host planet. The only one larger would be Charon and Pluto, but you can also almost consider them a binary. So if you consider them a binary, then it's not a moon. So there you go. So our moon is the largest in comparison. So let's give us Io. It's not the largest moon in the solar system, though. That would be Titan, I believe, which is larger than Mercury. You can fact check me on that, though. Drop it in the comments, let me know. Put one on kind of a freaky sideways angle there. I should have done some more of those in our solar system, but we'll make it really like there's a really crazy collision that happened here. And we'll put Tethys in kind of close. Alright. Are we going to stay in orbit? And what is this going to do to our tides and our weather? I wonder how much of a difference it'll make on Universe Sandboxes. Oh! Io just collided with something. Oh no. See that? Like I said, that's the problem. When things get too crowded, you're gonna have collisions, and eventually everything will kind of fall back into some sort of stability, but, meanwhile, life on Earth gets eradicated. Well, let's see. Let's see what happens to Earth here. And get a hailstorm of fire and dust. How are we doing temperature-wise here? Just a really cloudy day. Really good for the farmer's soil. All this space dust, growing some space potatoes like Matt Damon, the Martian. Matt Damon. Did anyone watch that movie? I kind of liked it. When you only have one character on screen pretty much the whole movie, I think they did a pretty good job of making it about as exciting as you can. I think I'm going to start rewatching the old Star Trek movies too, because I was always more of a Star Wars nerd growing up. But I did watch some of the newer Star Trek. I should say newer, but the new when they rebooted the movies in like 2006 or 2008 or something. I started watching them, so now I kind of want to go back and watch some of the old Star Trek movies. It's actually kind of interesting to see some of the older practical effects. I feel like in a lot of sci-fi movies lately, I don't feel as immersed. Whether it's the CGI looking unrealistic, the characters not being super compelling, and sci-fi movies are just hard to find good movies in general because in order to get a lot of really good outer space visuals, it's super expensive. So a lot of the really good movies or TV shows like The Expanse, for example, most of The Expanse takes place actually inside of dark hallways of a spaceship, and then once in a while they have some outer space footage, and unfortunately, really, they do that kind of to save budget because a lot of TV companies and streaming services out there, they don't want to put a massive budget into sci-fi shows because it is a little bit more niche. So a little bit smaller of an overall audience, and so I think a lot of times investors are afraid to drop big money. So that's why it's so rare that you have a really, really good, sci-fi show like The Expanse, or I've never seen Stargate SG-1, but I think it just got added to Netflix or something like that. So one of the streaming services that I have like most of them, so I don't remember, but Stargate SG-1 is also supposed to be one of the greatest ones, but it's really like every couple of years that you get a really good sci-fi movie or a really good sci-fi series. So yeah, let me know what are your favorite sci-fi movies and series. Let me know down in the comments. Um, I was actually thinking about maybe reviewing some more obscure sci-fi movies, but I'm just kind of curious what what the reception on that would be. Um, I'm not sure if I really want to get into the movie space because that's almost a completely different YouTube space. So we'll see. And then if you want to show clips of the movies, you really get into copyright infringement depending on what movies you're doing. So that's why most of the time when you're watching movie reviews, you'll notice people will use still pictures from the movie or they'll use very short clips, and that's because of a copyright law called fair use, which is very ambiguous, unfortunately. It doesn't just say you can use 7 seconds of a video for every minute of your video. It just says you can essentially reuse other people's stuff as long as you're making it creative and you're making it your own unique content, or it's for the purposes of education or to like inform about the video. It's the most vague law possible, and so that's why some companies will go after people harder than others, and that's why I'm always afraid to put stuff from movies in my videos and stuff because of that, because of copyright strikes. So video games are awesome because you're creating your own content technically, right? So everything that I'm doing here, I'm creating. I didn't make the video game, but um, and generally video games like to be shared so that people know about them. So you don't really get copyright strike for video games. I don't even think you can actually. So, oh boy, let's check this out. So we got struck, but let's see if half of Earth is still habitable or not. I was just rambling on here for a minute there. Let's do the flashlight. Okay, maybe it would be habitable if it wasn't all flooded. You can live in some mountains in the Andes here in Chile. You can live in the Rockies. San Diego, you're still okay for some reason. You guys always get perfect weather. Totally unfair. Even in apocalypse Earth scenario. Parts of Alaska. That's about it. The very most mountainous regions of North and South America aren't flooded. So it looks like our sea levels rose quite a bit. Obviously, this impact caused a lot of that. And let's just see what happens here. Let it ride for a little bit more and then we'll blow it all up. So thanks for joining me today. I hope everybody had a great day. If you had to work, I hope you got your work done. So I hope you're lucky enough to somewhat enjoy your job, enjoy what you do. Wow. So all the way out. Look at all those fragments. Speed it up a little bit more and just kind of get the final effect here. Looks like our hothouse is spreading. Oh no. Yeah, we also, had a bunch of new dust and stuff hit us. It doesn't look like it's significantly changed our mass, but super hot. Not a nice place to live. Now I'd imagine we're going to cool down because a lot of this heat is from impact, so we'll see what that kind of does to our atmosphere. Just kind of let it rock for a minute here. Or if you guys want to see the speed more. Sorry, I kind of have it stretched a little bit so that it fits better. Here, there you go. Now you can see the statistics a little bit better over there. Cooling back down. Do we even have our original moon anymore? Yeah, that's farther out. I put them all in pretty close too. That's my bad. Put Titan way out here. Deimos. Phobos. Those are the two moons of Mars. And you know what? Mercury's small enough. Mercury's smaller than Titan. Less massive. Mercury, you're a moon now. Deal with it. Oh. So I think theoretically the Earth could hold a lot of moons, but I do believe that moons themselves, moons themselves are temporary. We know that our moon is leaving us at a very slow rate. We have seen moons of Saturn cut into the rings and even start crashing into Saturn. So we know that moons are generally remnants of collisions, and that on at least galactic timescales, they're not permanent. Sort of like on very, very long timescales on Earth, rivers aren't really permanent, right? Um, they form probably from flooding. Who knows exactly how? They move water from place to place. Eventually, that source of water will change. The river will meander and move. They say, no man steps in the same river twice, because the water is not the same, and the man is not the same, or something. I butchered that, my bad. Alright, Earth. We haven't had any new collisions, because the new moons that I added were farther out. But I don't think that we're necessarily going to get habitable. Alright, let's blow it up. Boom, boom, boom. Goodbye. Alright, I hope everybody had an awesome day. I hope you learned something new. Let me know what you think. And then, like I said, let me know what you think about the theory of everything. Are we chasing dragons? Are scientists out of their minds? Do you think that possibly there are just different rules for the molecular level than there are for the cosmic level? Let me know. I don't like to crush anyone's dreams. As one of my commenters on Facebook said, something like, or it might have been on YouTube, but they said something like, I'm sure everybody told the Wright brothers that they were pretty crazy to think that they would fly too. So I think as scientists, we should always be encouraging new ideas, however difficult and challenging they may be. And if we can ever find a unified theory of everything, I think that would be absolutely amazing, because obviously it would simplify everything so much. So, as I said, thank you everybody for joining today. I hope